So hi guys, in this video we are going to see memory area and execution engine. So let's create one structure. So suppose this is our memory area. So memory area also having some sub type, or we can say memory area also classified in some subtype. So one is method area. Oh sorry. Yeah. So first one is method area. So inside method area, all the class level data that we have created, we have defined, we have written code for method, variables, everything. So that will come inside this method area. Second one is heap area. So all the object level, all the object as well as we have created an object for any class. So all the object and all the variable for object level, so that will come inside this heap area. So in method area we can say class level data. So all the static variable that will what happening when we are loading the class file, that time only it got declared, it got initialized that variable, so that is called class level data. So that will get memory in this method area. And all the object, once we have created the object of class, so all the variable that is defined on the object level, that will get memory in this heap area. And in heap area I also explained in previous video, there is one a string constant pool to store the a string data. So this is heap area. Third one is a stack area. So let's make it little bit bigger. So what happening ki all the threads, suppose in our program one thread is running, so all the thread will have their own a stack in this area. So a stack means ki in a stack last inserted data will be means last inserted will be accessed first, so last in first out in this scenario. So what happening ki if we are calling some method or sequence of method, one method calling to another method calling to some other method, that sequence of method, so all will be managed in a stack, and once the last one will be completed, then it will be removed from that stack, and then next it will starting executing the next one. So that's why it manage the sequence. We have written, we have a calling a sequence of method. So how to manage that sequence, which method should finish its execution, then which method should execute. So these stacks help threads to make the sequence, manage the sequence of execution. So a sequence of execution, this is a stack area. Another one is PC register. So PC register, whenever we are running any thread, so current thread or particular thread running on which statement. So if we'll check here, this is the code. So suppose this is by default main thread. So main thread currently running on this line. So how compiler will know ki thread is running on which line? So that PC registers stores the sequence currently executing line. So this PC registers stores the memory. See, basically it's a reference of the current executing line for that thread. And another one is native method stack. So if you will see, Java is not a basically machine level language. It's a high basically we can say ki it's a high level language. It's a human understandable language. So Java doesn't directly communicate with operating system. If you are trying to read some file, so file will be on hard drive, so it won't read directly. Internally it will call some function, and that function will call some function internally, and at the end all the functions that is implemented in C or C++, so that is called native. So these basically there are some library that is not a part of Java. JDK, that is separate language. So in Java also what we can do, we can create one library in different language, and that library we can use in our Java program. So that library that is written in different language, not a part of Java, it's called native method. So usually there are some function like how to assign the memory to particular variable, how to clear that variable, how to update that data in memory. So that is being handled by using C. So there are some native method that Java needs to handle this memory hardware things. So this is native method stack. So let's write down name of each block. So this is method area, this is heap area, this is a stack area, this is PC register, and this is native method stack. Native method stack. So what will happen, once the class loader will complete its process, then request will come to this method area. So whatever code we have written, according to that, all the class level data will be stored in this area, and this all are basically interconnected. So this one can communicate to this one can communicate to heap, this one can communicate to PC register. Basically it's all this is a part of memory. So it's not sequence, this one can't communicate directly to PC register. So let's move on to make this sequence. So these all are interconnected and they can access means anything. So in a stack area, heap is common for all the program, method is also common for all the class. So whatever we have written 10 class file or 100 class file, so all will be loaded inside that method area, and all the object of that class, so object and object level variable, all data that will come inside heap 1. But a stack is not the shared one. So a stack will have separate a stack for each thread, like thread 1, thread 2, thread 3. So I'm not writing complete thread 1, it's a T1, T2, and T3. So this will have a stacks. So suppose we are calling some method that will come inside this. These stacks. So what will happen, suppose if we'll go here, this is simply it's printing. Suppose we are calling one method, that name is sum. I'm not writing complete code, and some method is written somewhere else. So firstly this being called on the first line. Okay, so what it will do, when it will execute this sum, it will it will push that code to here, then it will go inside that sum, whatever data, suppose from sum it's calling some other function, that will come here. So all the sequence will be managed in this one, and once this one will complete its execution, this will be released, then this second last will be executed. Once second last will complete its execution, then this will be released, and so on. If we are calling one more function, so it will be keep adding and keep removing according to their execution, calling and completion of its execution. So this one can't communicate to this one. Both or all three are a part of a stack area only, but this stack can't communicate to another thread. So all the data that is there in this stack that is only available for T1. All the data that is available, that is a part of this one, so that is only available for the T2, and so on. So if we have 1,000 threads, so it will create 1,000 stack for each, 1,000 stack for each thread, and all will not communicate any other. So this is the stack area. PC register basically which a statement. PC register also, it is basically PC register also have for each thread they have PC register area. So for each thread currently it's executing which a statement, current pointer, so that will be stored in the PC register. So suppose 50 or 5 thread are running. One thread is running on this line, second thread is running on this line, third thread is running on this line, so on. So all will be stored in this PC register area according to thread number. So we can that JVM will know कि okay, thread 1 currently executing on line number 4, and thread 2 is currently executing on line number 5, and so on, all that things. But while executing this thing, they need some communication between hardware, like they need to write some memory, they need to locate some memory, they need to update the data. So they can't update directly by using Java code. So that time they need to call native function that is written in C. So all the C functions, so whenever we'll try to run any code, execute, so firstly class will be loaded, and then this object, this memory will be assigned to according to their respective uh, data, like class level, object level, a stack level means thread level, and PC register, and this native method. So all the native function will gets data, will gets memory in this location. So whenever we are trying to call some function that is native function, so that will simply, it will fetch from here, and then that's been called. So that native function, then it will go to the Java that C level, and then it will execute. But this, if you'll see, this is the stack. So this one also having some sub part, like on each thread there are some function, there are some variable also on method level or internal level, by thread level. So this will be also classified in some part. So let's see. So this stack will also classified in 3 part. First one is local variable array, second one is operand, I think LRA, I don't remember exactly. So first one is local variable array, that is basically it will stores all the variable that is locally, means suppose we have declared lots of variable in any function, in any method, so all that variable is called local variable. So that will come here in one part of this stack, that local variable. Second one is field data, so all the data on field level, that will come second part. And third one is operands, what was something like operand system, yeah. So basically second one is operand stack, that is basically intermediate function, if any intermediate function required to execute, that will have. And third one is frame data, so all the data will be related. Okay, I will give you reference for this thing. I don't think you need to go in deep such a way, but on this level you should know okay, this one have some classification, we can classify into that part. So this is basically complete architecture of memory area. So write down here. So this is complete architecture of memory area. Once this process is completed, then third part will come, that is execution engine. So I think execution engine will continue in the next video. So that's it for this one. Thank you.